Okay, so my name is Abel, and we are gonna have a talk about Backstage. We are planning to in the next 40 minutes. The way we are gonna structure the talk is to present you some real use cases that we have faced. How did we address them with Backstage, and some lessons learned that we got from this experience. So the first question that we want to address here is, why are you here? Maybe you are here by mistake. You think this is track 2, and this is not track 2. This is the talk about Backstage. Maybe you heard about Backstage and you want to know more about the capabilities that this framework is presenting. Or maybe you are a user of Backstage and want to know what is going on in the background. And maybe you're working with Backstage actively. You have also real use cases, and we can put some light on your path. So let's put everyone in these groups in the same page. In case you don't know, Backstage is this framework developed by Spotify to create developer portals. Version 1.0 was released in 2022. And usually is tied to platforms. Backstage is not a platform. It's just one component of the platforms. And it offers a unified view, usually, of your platform. The first pane of glass of your engineering capabilities. Kiri?
Yeah. And here we have a quick look into what Backstage looks like in action. I will not be going into details of explaining everything, but just as a glance, it has a very friendly interface of showing and having all of the resources, documentation, systems that you might have into your organization. Okay, and this QR code is going to take you to a demo of Backstage. So if you would like to find a little bit more about Backstage, what it looks like, maybe during lunch, then you can just quickly scan it and try it out. I'll give you a second. Okay, this blog post that we found on Stack Overflow is quite interesting because it's titled, "I spent 2 years trying to do what Backstage does for free." And it is a very good one because it shows that you might be having the same things that you want to do, but actually not knowing that there is a tool that can do that for free. And this is what we're going to be finding out in the next slides on the capabilities that Backstage offers. So what are the core capabilities from Backstage? Starting out with accelerating developer onboarding. How can Backstage help you out with that? Backstage offers a very clear and organized way to get you started as a new member to the team. What that means is that you will not have to spend time looking at different resources, looking at different tools, and searching out documentation or bothering your colleagues with questions where to find what. But you can do that simply just going to Backstage and finding all that you need. Next up, it improves the developer experience. As I mentioned, Backstage is this single... As I mentioned, Backstage offers all of these resources in one place. And all of your developers can have and share the same experience. They don't need to be switching context constantly by finding the tools or etc., etc. That does not mean that you will be getting rid of the tools that you have in your software landscape, but it means that you will be integrating these into Backstage. Next up, Backstage can help you orchestrate your self-service capabilities. Backstage can be your orchestrator for providing all of these platform capabilities by offering a user-friendly interface and offering that via software templates. It will also be one of the topics we'll be explaining more into the use cases that we're going to be having next. Backstage also is going to be your knowledge management system. How does it do that? It does that by having all of your documentation in one place, and you can easily search, you can easily find it and integrate it, and it is quite cool. Next, we have metric tracking. In case that at your company you have your own metrics that you are tracking for your organization, then Backstage can be integrated with other plugins and can show all of these metrics in one place. And last but not least, Backstage is highly customizable and extensible, and this will also be one of the topics that we'll be covering in our use cases. Yeah, Abel already asked the question on why are you here, but why are we here? As we quickly were introduced by Raquel, we are infra. Hi, I'm Gabrilinda, infrastructure consultant at ThoughtWorks. I've been working with platform teams, and I've also gained some experience working with Backstage. I'm not saying that I am an expert on Backstage, but I'm just sharing some experience and lessons learned about it.
Yeah, I'm Abel. I'm a lead consultant at ThoughtWorks, and I have been working with Backstage platform for a few years now. And this is how we are sharing. I'm not considering myself an expert in Backstage, but we are sharing here our experience working with Backstage with you in case it's useful for you. So, the first use case that we are going to explore, we explore this capability about how Backstage is customizable and extensible. So let's see how can we model and modify the system model that Backstage use fit in your organization structure. Imagine you have an organization, you work for an organization, and you want to map the software catalog and also the human registry of your organization, but the Backstage model doesn't really fit in the model of your organization. You also want to model the relationship, the ownership relationship, sometimes complex relationships, and you need to address that. Karin, how did you address that with Backstage?
Yeah. In order to give you a better overview of our solution, I first would like to give you an overview of what the organization structure looked like at the client, and then going on what Backstage system model looks like and how did we map these out. So at the client, it was organized in this way. So we had value streams, which could be community of practice or some platform team. And each one of these value streams was comprised of multiple products, 1 to multiple products. Each one of these products could have one or multiple product teams working on it. Don't ask me why it was done like this, but this is just the setup that we had. And of course, the product teams, they had the people working as part of them. Okay. And going on to Backstage system model, it looks quite complex, this diagram. I will not explain every single detail here, but what matters is that how does Backstage do its system modeling? It does this in 2 levels. First one is ecosystem modeling. The ecosystem modeling is how your technical software landscape is mapped at your organization. And as part of the ecosystem modeling, we have, as you can see, these 2 rectangular shapes, and we have domain, system, resource, component, APIs. Starting off, what is useful for our use case is domain and a system. What is a domain? A domain can represent some business value. For example, payments. And next, we have a system that can be, for example, some kind of process that fulfills a function, and that is part of this domain. And system can, as I said, can be part of the domain. Domain can have multiple systems. Now, the next level of modeling is the organizational entities. What does this represent is the human registry, as we had in our use case. So that is shown by having these 2 entities that are group and user. But how are these models actually connected together? What brings these 2 views together? It is the ownership. In Backstage, the concept of ownership is super important and crucial because it's going to show the ultimate responsible team for that domain or for that system. Now, how did we map this out? We have the core entities from Backstage. We also have our organizational structure, and we got started out. So we thought of having, for value streams, we're going to map it out to a domain, given that that's also the highest level of abstraction that Backstage has. And then this value stream, they have products, and the product would be a system. So a product also has a function, a feature that they're trying to deliver. And then we saw the product teams, given that they represent a group of people, would be mapped to a group. And then the members to a user. As we were doing the mapping, we found out that mapping value stream to domain, mapping a product to a system was all easy. But how do we map that a product can have multiple product teams working on it? And why is this a problem? Now, this diagram here is going to show how system and group is connected together, how this relationship is working. The system entity, as I mentioned, we have this ownership, right? That is very crucial in Backstage, can be owned by a group, or in our case, a product meant that can be owned or worked on by one product team. But this was not our case. We wanted to have a one-to-many relationship. And this would have meant that we needed to do something to show this relationship. We spent out a lot of time researching Backstage documentation, looking on what we could do and what Backstage actually advises you to do. One of the advices from Backstage is that you can customize this relationship, but you are a little bit on your own. You need to take care then of maintaining this customized relationship. You also need to make sure that this relationship is validated with all of the other entities that are part of the ecosystem. How did we achieve that? Well, even though this was not our favorite solution to do, to customize this relationship, we had to. So we thought of getting the system entity and actually defining multiple owners to it. I missed out on a concept of Backstage. So how does actually Backstage know that this system, or how does it register that into its catalog? That is done by having a YAML file, and you can then, just like in Kubernetes manifest, define a system. You can also define who owns that system. And in this case, would have been only one owner. And via our customization, we said that the system entity, we're going to actually give it multiple owners. In our case, meant that you're using Azure Enter ID for all of our groups, and we would have multiple Azure Enter ID groups in there. Then we added some other customization. I could go into more details if you're willing to talk about that after the talk, but it can get quite complex. And this resulted in us then having the system entity owned by multiple owners that we defined. What did we learn after doing this customization for the relationship of the entities together? We learned that you gotta thoroughly test these customizations. At ThoughtWorks, we do love testing, but sometimes the client projects, it might be hard to enforce that testing approach that we take. And they might not pay so much attention to that. But it is highly important to do that in case that, well, this customization is going to be breaking some other entity. Second is the total cost of ownership. What do we mean by that is that whenever you're introducing customizations, you also need to maintain them. You also need to make sure that they're not going to be breaking on the next Backstage release version. And that also you're going to be introducing tech debt. You might be taking some shortcuts to make this feature happen, to have it already in production and working, but then it's going to cost you more in the future. And third, scalability. Introducing a customization like this means that it is going to be working for some time or for a set of users, but it might not be scalable for future use cases. So whatever customization you're doing, it is important for it to also be scalable.
Okay, so another capability that we want to explore here is how Backstage can serve you to create a self-serve platform, and orchestrate some of your engineering capabilities. So imagine you are a platform team and you are creating a platform and you want the developers and the product teams to use your capabilities. So one great thing to approach that is to create a self-serve. How can you do that with Backstage?
So how did we actually do that? Our approach was to use Backstage scaffolding, software templates, and also create custom actions for scaffolding. But you might be wondering what even is scaffolding and software templates. Scaffolding is the actual process of generating new projects from some predefined templates. These predefined templates in Backstage, they are called software templates. And you can think of them as a blueprint, or they can look like a form where you can have some input parameters. And then based on that, it's going to create components and register these components back onto Backstage. This is just to show you quickly what the software looks like in action. So, as I said, it's like a form. You have some parameters. You choose who's going to be owning that component that's going to be registered back into Backstage. And you're going to hit next steps and then create. You can think of it as a pipeline or a GitHub workflow that fulfills a certain action. Now, over here, we are showing the solution that we implemented. So we thought, since we have this platform team that wants to have offer the self-service capabilities of the platform, to be the one who's going to be taking care of creating these software templates, as they're also the ones who own it and also the ones who know their platform the best. And these software templates, they would then be used by the developer or product team. What would these software templates actually include? Could be you want to create some infrastructure component, could be that you want a new database, you want some Azure DevOps build agents, etc. It is important to notice that on this diagram here, we have Backstage as a separate layer. And then the platform, we had it as also a separate layer. This is to show that whenever you are starting out with these software templates, you need to choose on what responsibilities Backstage is going to have and what responsibilities your platform is going to have. And it's only by having this collaboration between the both that you can achieve what you want. And in our case, we said that Backstage is only going to be the orchestrator. It's only going to be the top layer. It's only going to be the one just to trigger or be the form to input some parameters. And then in the background, it's going to trigger all the automation from platform team that has in place. What this looked like from platform team, it was that user inputs some parameters, creates some product config file. It's pushed to the repo that the platform team owns for it. And it's going to create a PR and auto merge it. And then have some other Azure DevOps pipelines that are running in the background. How did the custom actions part come into life or play into this? Well, as I mentioned, we create a pull request, and then we're also auto merging. How can you achieve that on Backstage software templates? The software templates, they have some predefined set of actions that you can use, but in case that you want to achieve more, then you have to customize these actions. In our case, for creating a pull request, there was already an action for it, but there was no action that actually also sets this auto-approve flag to it. So we had to customize it. It was very doable. It was all easy. It's also to show you that you can create your own custom actions in case that you want to achieve more with software templates. Now, this is to show you a little bit on what the self-service platform capabilities look like before having Backstage software templates. So the usual flow was that a developer is going to go to a platform team, make a request, tell them, submit it to some Jira or Azure DevOps board. Then the platform team is going to take care of the request, maybe not this sprint, maybe the next sprint, whenever they have it planned out. And then platform team is going to execute the automation in place. You're going to be pinging again, platform team, hey, is that done? Is that not done? And then the platform team is going to come back to you and tell you, well, the resources are up now, and they're ready to use. But how does the process look like once you have Backstage software templates? This can very much shorten the process because as a developer or as a product team member, you just go on Backstage, you choose a software template for the component that you want to create or the capability that platform team is offering. You trigger that software template, and then you're going to see the components or that you requested register back on Backstage. This is not to say that Backstage is going to magically do this by just spinning out some software templates, but the platform team needs to also want to have these self-service capabilities via Backstage, needs to do a lot of automation in place to have this process shortened. Now, after doing all of these software templates, we realized some shortbacks of Backstage. That once you are creating or you are choosing a software template to create some component, the developer is a bit left out in the dark. You do not get any kind of feedback of what happened with the automation that was triggered in the background. So Backstage is still just the top layer. And for example, it might be triggering some Azure DevOps pipeline or some GitHub workflow. And it does not have a way to show you that this workflow or this pipeline actually was successful or it failed. So we needed to show the developers what happened in the background. And we did kind of like a workaround. We could not get like the full feature that we wanted in place, but the way that we did it was that we installed Azure DevOps plugin. What this plugin is going to do, so if you install it on Backstage, it's going to give you an overview of all of the Azure pipeline builds. And you can also see the docs for it. You can also see the Kubernetes resources that are related. You can also see the pull requests, code insights, code coverage, and basically offers you an overview of your CI/CD environment. And what we did is that after triggering the software template, we redirected the user to an overview of the Azure DevOps plugin, where they could then match the pipeline that was running in the background to the pipeline, the latest one that is showing on the Azure DevOps plugin. It's not the greatest way, but it's also to show that sometimes with Backstage, you cannot get all the automation that you want in place. What were the lessons learned for scaffolding and software templates and for this use case? Well, you want to have some feedback loop in place. You want to give some feedback to your developers on what happens when you are using software templates. You also need to decide on the responsibilities that Backstage is going to have and that your CI/CD environment is going to have, which in our case for Backstage was only the orchestrator. And third, you can use custom actions to get the level of customization that you want for your use case. Now, we're going to get a little bit more technical with Backstage, and Aben is going to talk about deployment of Backstage. Now, let's suppose that you are implementing an engineering platform and your team is in charge of implementing the internal developer portal. Now, there are different styles of deployment on Backstage, and your team is still in the progress of defining the level of control and the host that is running the CI/CD pipelines. Now, how did you do the deployment of Backstage?
Yes, one of the first decisions that you need to take when you work with Backstage is how you are going to deploy that. So before jumping into our approach, let's scratch the surface about the package architecture of Backstage. Backstage is a 3-tier application, front, back, and storage, and is designed with scalability and modularity in mind. Usually the elements of Backstage are self-contained, but can be extended via extension points or new libraries, or even you can plug plugins. There are a lot of plugins. The plugin ecosystem in Backstage is vast, and you can develop your own plugins. So you can see in the diagram that you have the app, the front-end part with a core and some plugins and libraries, and the backend. There are also some common libraries and some plugins that are called isomorphic plugins that can work both in the front and in the back. Okay, Backstage officially support container-based deployments. And the first type of deployment that they support is creating a container. If you think a bit about what I have said, I mentioned it's a 3-tier application. So if you deploy a container, where is the front? Okay, Backstage has a plugin that serves the front end to the user when you deploy this monolithic, let's call it monolithic deployment. And you can build it with a single stage or a multi-stage Docker file, and you can build your container and deploy it. This is the simplest approach. It's fully supported by Backstage, and also Backstage provides some examples in the documentation. But if you want to deploy a more traditional front-end backend, you can split it. As I mentioned, the components are self-contained, so you can easily split. Backstage works with a monorepo approach, so you can build both the front-end bundle and the backend container separately. In this case, you need to take into account that some of the functionalities of this plugin that I have just mentioned are lost. You need to build everything in the bundle by yourself, for example, the configuration, and you are missing some functionalities from the plugin. That provides you like greater scalability, for example. But if you want more, you can deploy multiple instances of the backend. Backstage takes care of the synchronization, but the external resources like the database, or if you use cache or you have integrations, they cannot be replicated. And you need to take care of that. And if you want even more, you can split the backend in different plugins. You can have different instances running different sets of plugins. That enables your team, for example, to have multiple work streams with different life cycles. You can have a backend instance that has like, I don't know, a really high pace release, and another instance that you barely release because it has no changes. So eventually, what did we choose? The simplest approach. We didn't have scalability requirements. We didn't have like different work streams. So we chose the monolithic approach. What did we learn from that? The best way of deploying Backstage is your company deployment style. Backstage has really flexible deployment styles and provide a wide support how to deploy Backstage. So your decision shouldn't be driven by the Backstage limitations, because there are barely limitations. But there are some limitations, another lesson learned. If you decide to split the front-end and the backend, you need to know that in the front-end, you are building a front-end application, a front-end bundle, and you are building a backend application. And the third one, this is something that we didn't like, even though we chose the monolithic approach, the single container approach, the multi-stage build that we chose in the beginning, the build time is not negligible. Remember, Backstage is building each plugin as a separate project. So it may take some time to build, sometime meaning few minutes. But if you want to do like continuous delivery or frequent releases, it may hit your build time.
Okay, then jumping in on next to a very beloved topic, let's talk about security and Backstage. What is the scenario? So when starting out with deploying the developer portal Backstage, the company might want to have Backstage publicly available on the internet for easier access. But your team is also in charge for the design and the implementation of the security measurements in place to make Backstage as secure as possible. Now, how did you do security, Abel?
Okay, security is always tricky. So Backstage has a threat model in the documentation where they define what they call a trust model. In this trust model, they define several roles, being external users and internal users. External users are users that don't belong to your organization. They don't have an identity in your Backstage. Internal users, on the contrary, have an identity within Backstage. Additionally, there is our builder role. Builder are contributors to Backstage. Sometimes you develop plugins or libraries for Backstage, and sometimes you bring third-party plugins from the plugin ecosystem. These are like third-party contributors. And eventually, you have the operator. The operator is the role that is in charge of deploying, securing, configuring, and working with Backstage. Why are these roles important? Because Backstage defines clearly the responsibilities in this threat model about the Backstage. Backstage is in charge of the protection of unauthorized access to the platform, and also they have some mechanisms to avoid tampering with data. Since March, version 1.24, I think, they also provided some authentication between the front end and the back end with the new backend system, and they also provide an authorization mechanism via permission system, where you can define policies to define authorization within your Backstage. Being said that, everything else falls under the umbrella of the operator. So Backstage is not designed to be deployed in the public internet. So if you want to do so, it's on your own. You need to put the measures in place to avoid denial of service or machine attacks. You need also to implement authorization mechanism. The mechanisms are there, but you need to implement the policies. You also are in charge of secret management, audits, and vulnerability management via dependencies. So what did we do to deploy Backstage in the public internet? We tried a zero trust approach. So we deployed Backstage, and we implemented authentication using two different identity providers and resolvers. Here the resolvers play a key part because Backstage allow multiple identity providers, for example, Microsoft Entra and GitHub, at the same time. Having two different identities within the same system could lead to two different identities in Backstage for the same user. So the resolvers play a key role because they can match two identities in the same Backstage user. Then we use the permission system to implement authorization within the front end. And symmetrically, we implemented authentication supportedly natively by Backstage, and also the permission system for the backend. And then we have the integration, what Backstage called integrations. And Backstage handle the integrations with the regular authentication and authorization mechanisms like OAuth. I mean, they are widely supported. And we implemented this integration this way. What did we learn from this approach? It's critical to read and understand the threat model from Backstage and understand what is your role in the deployment of Backstage, because misunderstanding these responsibilities could lead to unsecure deployments, especially for the public internet. And we learned the hard way when we implemented this approach that Backstage is not designed to be deployed in the public internet. So we had to add additional mechanisms to deploy Backstage in the public internet.
All right. And last but not the least important topic at ThoughtWorks, as I said, we love testing. So we're going to be talking about testing and Backstage. Let's take on the use case. Given that you are working with Backstage and you are going to be extending the existing functionalities and all of the customizations that you have, then you need to also use some modern, enhanced development practices, and you want to apply test-driven development when possible. How do you do testing?
Okay, we all love testing, right? Okay, thank you. So what happened to one of my teams when we approached Backstage is that we saw a lot of moving pieces. We wanted to develop permissions that I mentioned before for Backstage. We wanted to develop new front-end components. We wanted to develop backend plugins. We wanted to develop scaffolding templates. We wanted We wanted to ingest the catalog from GitHub. We wanted to do a lot of things. So we were a bit overwhelmed of, okay, how are we going to test that? So what we did was to design a test strategy. The first thing that we did was to categorize the components. We created several categories, like internal business logic and front-end. We also identified the parts that are related with plugin interactions. We identified some APIs. Remember, a 3-tier application, so the APIs are there. You can test them. And we also identified side effects of our test in the integration. When you create a repo, for example, you want to know that the repo is there with the configuration. When you create some resources in your cloud provider, you want to make sure that the side effect is there. After creating these categories, we started using the regular tools that Backstage is providing. Jest and React Testing Library are used in Backstage for the unit tests, but there are also there is also a plugin that provides you testing functionalities. With those two, we were able to do TDD for our internal developments. So those two allowed us to shift tests to the left as much as possible and started developing new functionalities in Backstage as we move along. We also saw the APIs, and we started creating really thin contract testing. And we found that to test the side effects on the integrations, we require some higher level testing. So we decided to implement few end-to-end tests and also some synthetic monitoring, which creates synthetic traffic in your production environment. And then you identify this traffic and configure alerts in your observability to receive information about this traffic. That was our approach. What did we learn? Automate your testing. Backstage has a lot of moving pieces, and you won't be able to work with Backstage unless your tests are automated. In our case, we learned that the design strategy was a great tool to categorize and cover all these use cases that we needed to cover all our day-to-day development work. By the way, the testing strategy is a live document, so it's not something that we designed in the beginning and is not changing. We found that even though we love to shift tests to the left, we found that some use cases were not covered by unit tests and integration tests. So we found that we needed some higher level mechanisms to test Backstage. This is always tricky because these higher level tests are slow, are expensive, and sometimes are fragile, but we needed them. So we eventually adopted them. Did I mention that you must automate your tests when working with Backstage?
Just letting you out there. Okay, just to wrap things up, what are our main takeaways after having experimented with Backstage? So, Backstage is in the adopt ring of the platforms quadrant in the ThoughtWorks Technology Radar since October 2022, and that has to say a lot for this as a tool. It is complex and it requires some tailoring and customization in order to extract all of its potential and to fit the organization's need. And also the Backstage is becoming the de facto standard to build developer portals. Sure, there are also other tools that can help you build your internal developer portal, but Backstage is still the reigning one and has extensive documentation on it. Thank you, and we are open for questions.